This lesson is on finding GCF. Now, in the next chapter, what we're going to be doing is called factoring. Factoring is undoing multiplication. So the first thing we're going to learn how to factor is called the GCF. Now, you may have heard this in the past. GCF stands for greatest common factor. Remember, factors are things you multiply together. So that's what factoring is. We're unmultiplying. There's two things you have to look at when you're doing the GCF. You have to look at the numbers in front of the variables. You have to look at the coefficients and the constants. Right here. And you have to look at the variables. I'll do it in variable. For the coefficients and the constant, you're looking for the largest number that can divide into all of them. You do that. A number that can divide into all of them, and we want it to be the biggest number. Variables are different. If all the terms have the same variable, then my GCF will be the variable with the smallest exponent. The key is they all have to have that variable. So it's a number that divides into all the coefficients, and it's the largest one, but it's the smallest exponent of the variable if they all have the variable. So everything else is okay. I mean, as far as the numbers go, they all have to be divided, and they all have to have the same variable for it to be the GCF. Now let's take these two pieces. First, let's look at the coefficients. The 6 and the 9. I need the biggest number that can divide into 6 and 9. And the only number that can divide into both 6 and 9 is a 3. Now, notice they both have x's. Since they both have an x, I choose the x and the smallest exponent to be the GCF. Look at this next one. I've got a 6, a 4, and a 2. The biggest number that can divide into all three of those is just the number 2. So my GCF has a 2. Now notice, this one has an x, this one has an x, this one has an x. That means my GCF will have an x, and the smallest exponent is 1, so it's just 2x. Look at this one. We've got an 18, we've got a 6, and we got a 24. Now I'm looking for the biggest number that divides into all three. Now notice 6 can go into both 18 and 24. So my GCF turns out to be 6. Notice they all three have x's. That means an x will have to be part of my GCF, and it's going to be a 1. It's x to the first power. Now this problem's got two variables. When you're dealing with two variables, they both have to have the same variable. That's key. Now first, let's look at the 5 and the 10. They both are divisible by 5s, so we put a 5 for my GCF. Now, this one has an x. Hold on. This one has an x. This one has an x. So we have to include an x. The smallest exponent is 1. Let me erase that. Like that. Now, also notice this one has a y and this one has a y. So we have to include a y. The variables have to be in all the pieces for it to be included. Here's an example. Now first, I look at the numbers, 15, 10, and 30. All of those are divisible by 5. So we put a 5 here. Now, this one has an X. This one has an X. The third one doesn't have an X. Since the third one doesn't have an X, my GCF will not have an X. The third one has a Y, but the other two do not have the Y, so the Y will not be included. So the only GCF they have is the 5. None of the X's go in the GCF because they don't all have the same variable. Now, when we're factoring out the GCF, we're turning it into a distributive property problem. Our answers are going to look like this at the very, very end. You will have a parentheses with something in front, and that's the GCF. We'll put something in the parentheses, and what we put in the parentheses is what we get when we divide by the GCF. So we're undoing the distributive property. We're turning it back into what it looked like when we did chapter 5 with the multiplications. Now, let's start with this one. My problem's going to look like this. I'm going to have something in parentheses. I'm going to have something in front of a set of parentheses. Down here is going to be the GCF. Inside is what I get when I divide by the GCF. So first let's figure out the GCF. What can I divide into both the 9 and the 6? The largest number that divides into both of those is a 3. Now, notice that they both have X's. So I choose the X with the smallest exponent to go on the outside. Now, what we're going to be doing is dividing each coefficient by 3 and taking 2 X's away from each term. That's why when we're dividing, we're taking X's away. So of course, 9 divided by 3 is 3. If I take 2 X's away from X cubed, I'm left with a single X. Then I divide the 6 by the 3 to get 2. If I take 2 X's away from 2 X's, there's no more X's. So whatever's on the outside, you divide into each term above it. Let's look at this one. Alright, so we're going to have a GCF out in front of a set of parentheses. Let's start with the coefficients. 3, 12, and 9. The biggest number that can divide into all 3 of those is just a 3. Now notice, they all have X's in common. So we're going to choose the X with the smallest exponent, which is just X to the first power. If it helps you, you could do this, I guess. You could say, okay, I'm dividing that by 3X because that's my GCF. It could help. So 3 divided by 3 is 1. X to the 4th divided by X means I'm taking 1X away. I've got X cubed. When I'm dividing X's, I'm not going to have the same amount of X's left over. I'm taking some away. And negative 12 divided by 3 is negative 4. I take 1X away from X to the 5th. Left with X to the 4th. 9 divided by 3 is 3. I take 1X away from 1X. I'm not having any X's left. This is the final answer. Alright, let's look at this one. Here's my GCF. Here's what I get when I divide by the GCF. Alright, so let's look at the coefficients. 10, 5, 20. They're all divisible by just a 5. Now, Notice all three of them have x's. That means we put an x in front with the smallest exponent. Now I'm going to divide everything by 5x. 10 divided by 5 is 2. I take 1x away, I'm left with x squared. 5 divided by 5 is 1. I take 1x away from x squared, I'm left with an x. Negative 20 divided by 5 is negative 4. I take 1x away from 1x, and there's no x's left. Your exponents have to decrease. Alright, now let's do this one. Let's look at, let me just draw the little boxes out. Let's say I have this, and here's my other piece. The number 7, the number 2, and the number 1. What do they have in common? The only thing they have in common is a 1. So in this situation, I can't really factor anything. So what you would say is it says it has no GCF other than 1. Which means I can't factor anything out of it. I'll talk more about this later on in the next section, but for right now, you can't factor anything. You would leave it alone. So if you were looking for the final answer, you would say this would be the answer. You would say something like, cannot be factored. Or you might say no GCF or something like that, but if you can't factor anything out, that's fine. You don't have to be able to factor anything. All right, let's take this one. I'm going to draw my little boxes in. All right. We're going to start with the numbers 4, 8, and a 2. They're all divisible by 2. So we're definitely going to put a 2 in the parentheses. Now, this one has an x. The second one has an x. The third one, there's no x. Since the third one does not have an x, there cannot be an x in front of the parentheses, because that's not a greatest common factor. So the only GCF this one has is a 2. So we're dividing everything by 2. Hold on just a second, y'all.
Okay. Very good. Phone's ready. Okay. Okay. Alright, I'll take it.
Okay, sorry, y'all. I had to take a phone call and I didn't know how to pause this. So, anyhow, 2 divided by 4 goes into 2 2 times. I can't take any x's away, so x's stays the same. Negative 8 divided by 2 is negative 4. Can't take any x's away. 2 divided by 2 is 1. And there's no x's to take away, so this is the final answer. Alright, let's look at this one. Start with the numbers. 14, 7, and there's a 1 in front of this one. So the LCD, our GCF, there's nothing that can divide into both a 14, a 7, and a 1. So we don't put anything in the parentheses as far as the number goes. But Notice they all three have x's. So we're going to put an x in front with the smallest exponent. That's the GCF. So we're going to end up dividing everything by x to the 4th. Now, the 14 is going to stay where it is. So when I'm dividing by variables, we're going to take 4 away from the 9, x to the 5th. The next one, we can't do anything with the 7. I take 4 away from the 5. I'm left with an x. I can't do anything with the 1. But if I take 4 x's away from 4 x's, I have no x's left. This is what goes in the parentheses. The first term, the x's decreased. The second term, the x's decreased. And the third term, I took away all the x's because it was exactly the same in the top and the bottom. Sometimes it's just a number in front. Sometimes it's a variable in front. Sometimes it's nothing in front. This one's got 2 variables. Alright, so start with the 4 and the 8. The biggest number that can divide into both 4 and 8 this time are, look, 4. We can definitely divide by 2's, but we also want the biggest, which is a 4. Now, notice they both have x's, so I'm going to have an x outside the parentheses, x to the first power. They both have y's, which means I'm going to have a y on the outside of my parentheses. So this time, we're dividing by 4, an x, and a y. Right, so 4 divided by 4 is 1. I take 1x away from x squared, I'm left with an x. If I take 1y away from 1y, there's no y's left, right? If I take $1 away from $1, there's no dollars. If I take a y away from a y, there's no y's. And the second one, 8 divided by 4 is 2. I take 1x away from 1x, and there's no x's left. I take 1y away from y squared, and I'm left with a y. That's the final answer. Let's do another one that's got 2 variables. Alright, so we'll start with the numbers in front, 12, 6, and 9. The biggest number that can divide into all 3 of those is definitely not a 4, a 3. This one has an x, this second term has an x, this third term has an x. So on the outside will be an x. This time though, notice this one has a y, this one has a y, but the third one has no y. Because only 2 of them has a y, we cannot put a y on the outside. Only 2 has the y, so no y goes on the outside. So we are dividing each one of these now by 3x. The y's will stay a part of the answer. Alright, so let's see. 12 divided by 3, we'll get 4. I take 1x away from x squared, I'm left with an x. And I've still got the y. Next one, I divide by negative. Divide negative 6 by 3, we'll get 2. Oops. Take 1x away from 1x, the x's go away completely, and I'm left with a y next to this 2. Then 9 divided by 3 is 3, and I take the x away, and there's no more x's. Alright. Negative GCFs. Some of these problems you're going to have negative GCFs, and the only way you can tell if it's negative is right here. First term is negative. First term has to be negative. Now we're going to do it the same way, it's just we're going to have a negative sign in front of the parentheses. Let's look at some examples of this. Alright. Whoops. Okay, so I'm going to draw my little box again and put my parentheses. So we look at the negatives. First term is negative. So I automatically know my GCF is a negative number. What can I divide into both 6 and 12? Biggest number is negative 6. Now, notice they both have x's. X with the smallest exponent. This time, we're dividing by a negative, not just a positive. We're dividing by a negative. So if it helps, you could do this. Negative 6x, negative 6x. Negative 6 divided by negative 6 is positive 1. And I take 1x away. Positive 12 divided by negative 6 is negative 2. And I take 1x away, and this is the answer. Alright, let's look down here at this one. First term is negative, so I'm definitely going to have it negative in my box. Alright. Now, I've got a 2, an 8, and a 4. Biggest number that can divide into all of those is 2, so it's negative 2. There's nothing, I mean, they all three don't have an x, so we don't put any x's in there. So the GCF is just a negative 2. Alright, so I'm going to divide this time just by the negative 2. Negative 2 divided by negative 2 is positive 1. X cubed. 8 divided by negative 2 is negative 4. X squared. Negative 4 divided by negative 2 is positive 2. Let's do a couple more of these. So I'm going to just draw my box underneath here. Alright. Notice the first term is negative, so my GCF will be negative. Now I've got a 9, an 18, and a 27. The biggest number that can divide into all three of those is a 9. Now notice this time they don't all have an x, so the only thing on the outside is going to be a negative 9. So I'm dividing everything up top by negative 9, so we'll get positive x squared plus 2x minus 3. If you need to, write it underneath. Negative 9, negative 9, negative 9. Like this last one, it's definitely got a negative in front, so it's a negative GCF. They all have x's, so I definitely have an x as part of my GCF, and it's going to be x with the smallest exponent. Notice there's no number that can divide into the 1, the 2, and the 5, so the GCF in this one is just negative x. So we're dividing everything by a negative, which makes everything, changes the signs, and we're taking 1x away from everything. So negative x cubed divided by negative x is positive x squared. Negative 2x squared divided by negative x is a positive 2. Take 1x away. 5x divided by negative x is negative 5. Take the x away. We will use negative GCFs coming up in the next type of factoring. So make sure you pay attention to this. Listen to this as many times as you need to.